Welcome to Client Communication Issues, the fourth lesson of Step 14, Maintain and Troubleshoot. In this video, I'll walk you through the interactions between the client and the Semantic Endpoint Protection Manager. Then we'll go through the different stages of the heartbeat process. After learning about client to SEPM communication, we'll locate and configure client debug for communication issues. And we'll apply the gather evidence, research, and repair methodology for resolving communication issues. At the end of the video, we'll do a quick review of how to check the client status on both Mac and Linux clients, as well as cover some typical scenarios for client communication issues. Let's get started. The Semantic Endpoint Protection Manager manages client computers that connect to your company's network. The SEPM distributes policies and content. It also gathers logs to provide operation and protection status of clients in your network. The SEPM creates reports and alerts to monitor the environment. And based on the security status of your environment, you can use the SEPM to respond to events. Examples include a missed scan or content update failure. The SEPM works with an embedded or MS SQL database for storing content, logs, and policies. The SEPM uses Apache web server to provide communication to the SEP clients. Communication takes place between the client and SEPM using HTTPS protocol. Client to SEPM communication uses two types of commands. GET means that the client initiates and downloads data from the SEPM, and an example would be a GET command downloading a new policy update or content. The POST command allows the client to upload data to the SEPM. An example of this would be logs or operational state information. Whether your clients are in push or pull mode, the client always initiates the GET request. The heartbeat interval is the frequency the client uses to connect to the SEPM. During a heartbeat exchange, the client sends data, such as logs, discovered applications, and inventory. The client may download updated content and policies. For more information on the client communication and heartbeat process, see the URL shown on the screen. When initiating a GET request, the client receives policy updates, product and content updates, client configuration and communication changes, as well as commands to be executed. A command can be a scan or a request to run live update. When initiating a POST request, the client sends new log events and operational state information. Operational state information includes data such as the last time the client ran a scan and virus definition dates. Heartbeat content varies depending on the client group. When checking in with the SEPM, the client monitors the parameters in the client's silink.xml file. Along with communication parameters, the silink.xml file provides the SEPM certificate. Before the client can authenticate to the SEPM, the certificate parameters need to match the client certificate parameters stored in the client's silink.xml file. The silink.xml file also contains the log settings that clients use when uploading logs to the SEPM. When you think of registration, you may think of it as a one-time process. But in the case of client-to-server communication, remember that SEP is client-centric. Client registration is the check-in process. It happens every time a client checks into the SEPM. The only difference is that the client is not known. The check-in adds the client to the database. Note that policy and content delivery, as well as registration, are performed using a series of communication requests over TCP ports. We'll talk more about this in the next topic. In this section, we'll go through each of the checkpoints in the client heartbeat process. The heartbeat sequence has several checkpoints in which specific operations occur. In checkpoint 1, the SEP client reads the silink.xml file to determine the available SEPM using the management server list. If it finds a SEPM with a higher priority, it connects to that one first before moving over to a lower priority SEPM. Checkpoint 2 is where the client connects to the SEPM. And in checkpoint 3, the client sets the session timeout in the instance that it's unable to establish the connection within 30,000 milliseconds. So if it can't create the session, the check-in terminates until the next heartbeat. For more information on the heartbeat process, see the URL shown on the screen. Also note that for installations using load balancing and failover, the client randomly selects a management server in the priority 1 group. If there is no response, the client tries other servers in the priority 1 group. If there is no response from there, it's going to go to the servers in the priority 2 group. During checkpoint 4, the client retrieves the index2.xml or the index2.dax file from the client group outbox located in the SEPM and parses the file to determine if anything has changed since the last heartbeat. In addition to server and group identification, this file contains the checksum and last modified date and time of the client's communication, configuration, and policy files located in the outbox. Each file in the client group outbox folder contains files with both .xml and DAX extensions. Clients conserve bandwidth by only downloading the DAX file if it already has the version of the existing content used to create the DAX file. If clients do not have the existing content, the client downloads a new XML file. Note that the SEPM uses a version of Google's open source XDelta technology to create these DAX files. The SEPM also uses the same underlying technology to host content and product update deltas. The index2.xml file contains the checksums and last modified times for the client's communication, configuration, and policy files located in the client outbox. The client compares the index2 file with its files to determine the DATs to download. In checkpoint 5.1, the heartbeat is conducted using CCARs. During the heartbeat, the client checks the live update policy on where to retrieve updates. Note there isn't a checkpoint 5. It immediately jumps up to 5.1 before moving to 6. In checkpoint 6, the client performs a GET request to retrieve the specific file names identified in checkpoint 5.1. You may see a checkpoint 7 where the client uploads logs, learned applications, and unmanaged detector information. And the heartbeat content can vary from client group to client group. For example, if you do not configure a client as an unmanaged detector within a group, there is no information to upload. In checkpoint 8, when the client is in pull mode, the clients disconnect from the SEPM and heartbeat again at the next interval. If configured for push mode, the client remains connected. Then in checkpoint 10, the client indicates that the heartbeat is complete. Now that we've covered how client communication works, let's talk about how to gather evidence when troubleshooting a client communication issue. When troubleshooting a problem, you gather evidence, research, repair, and validate. Sometimes the line between gathering evidence and research becomes blurred. Here are some common scenarios when troubleshooting client communication issues. After documenting the symptoms, you can determine if the issue is reproducible and if it's impacting multiple clients. Gathering evidence expedites the troubleshooting process. When gathering evidence for a client communication issue, use the following process flow. Review the client status icon on both the SEPM and client to see if it shows as communicating. Then check the policy serial number on the SEPM and client to see if the policy serial number matches. You can evaluate connectivity with tools like Ping, Telnet, and SEPM reporting from the web browser. Identify networking problems by taking a look at the firewall. If client communication issues impact a segment of clients, gather Apache logs from the management server. You can also debug directly on the client to shed light on why the communication is failing. I'll walk you through each of these steps in the video. The first step is to review the client status on the SEPM. The green dot shows when the client loads operational status information. It'll stay green during the client heartbeat. Note that you can change the view depending on the type of information that you're collecting. If you right-click on a client entry, you can choose to run commands and select properties to view client details. If the client is not communicating with the SEPM, and the SEP admin needs to identify if the client has a current policy serial number, you can also query the information via the registry. Retrieving the policy serial number via the registry is useful if the SEP admin does not have RDP access. However, the SEP admin can remotely connect to the machine's registry. For more information, see the URL on the screen. Here's a client connected to the SEPM without any issues. On a Windows client, the green dot shows when the client connects to the SEPM. It disappears as soon as the heartbeat finishes, or if the client fails to connect to the SEPM. If the dot is yellow, it can be for various reasons. Here's a breakdown of the different icons that the user may see in the system tray. If the shield does not have a green dot, it means that the client is either offline or unmanaged. Unmanaged means that the client doesn't connect to the management server. The green dot means that the client is connected and communicating with the management server. All components of the security policy protect the computer. If you see a yellow dot, it means that the client has a minor problem. The client could be having communication problems, or virus definitions are out of date. If there is a red dot, the client has a significant problem, such as an expired license or a problem with one of the protection technologies. For example, network threat protection could have a problem with the firewall component. To learn more about this topic, see the KB on the screen. Check the policy serial number on the client to see if it matches the serial number that displays in the SEPM console. If the endpoint communicates with the SEPM and receives regular policy updates, the serial numbers should match. If the policy serial numbers do not match, you can try to manually update the policies on the client computer and check the troubleshooting logs. To view the policy serial number on the client, open the user interface, click Help and Support, and select Troubleshooting. In the Management section, review the policy serial number. If the serial numbers do not match, you can perform a manual policy update to check whether or not the client receives the latest policy update. If the system does not accept the update, there could be a problem with the client and server communication. Note that for clients configured for pull mode, the management server downloads updates at regular heartbeat intervals. You can change the range so that the endpoints download policy changes more quickly. After communication completes, check to see if the policy serial numbers match. If the SEPM is offline, try a ping command from the client. The ping command allows you to check whether a specific IP address is accessible. It works by sending a packet to the specified address and waiting for a reply. The command is used primarily to troubleshoot internet connections, but you can also use it for network troubleshooting. Use Telnet to determine if you can connect to the SEPM over the configured communication port. In this example, the client cannot connect to Serve2 on port 443. You can also test connectivity by browsing to the SEPM reporting website using any supported browser. If the site is not available, there may be issues on the SEPM side. You can access this site from the client without having to RDP into the manager. If you're experiencing slowness or connectivity issues, Traceroute can identify routing problems. You can see the number of hops to establish the connection. The firewall can prevent machines from interacting or mirroring a network connectivity issue. To see if the problem is firewall related, temporarily disable the firewall and attempt another heartbeat. If the client comes online, then the firewall can be configured to permit the required communication ports for SEP. Note that you only need to perform these steps on the Windows firewall. The SEP firewall is hard-coded to permit traffic to the management server list. You can also reference the access.log on the management server to determine whether the client can connect. Before reviewing the access.log, enable Apache logging in the httpd.conf file and allow the endpoints to communicate with the manager. Reviewing the Apache logs can shed light on whether the clients are having issues, checking in with the SEPM from the server side. It's also useful for troubleshooting high bandwidth issues or if multiple endpoints are offline in the environment. The access logs record the files requested from the server and whether communication was successful. Disable the log after viewing because logging does consume CPU resources and hard disk space. For more information on troubleshooting communication issues and how to configure Apache logging, see the articles shown on the screen. The final step is to gather debug logs to determine if the client has communication issues. Client debug allows access to logs that are not usually available and helps create a timeline of the events leading up to the problem. Debug logs record product actions by specific components, including the client heartbeat. The logs also display error codes that allow support to see which component is causing the issue. In the instance of client heartbeat, it may be a misconfigured Sylink file or an unavailable management server. Debug is not always active, as it can flood the logs with events of no consequence. It can also cause a significant increase in system resources. On the Windows client, you can enable debug logging under Help and Support, Troubleshooting. The client UI is the preferred method to turn on debug when the system is available. Note that VP Debug controls the logging for the virus and spyware component of SEP. SMC debug logs are useful for troubleshooting client-to-SEPM communication problems and client functionality issues. This option can also be enabled for troubleshooting issues with group update providers. When enabling client debug, turn off tamper protection. You can disable tamper protection in the SEPM or the SEP client UI. Enable logging in the SEP client UI or the Windows registry. When enabling logging, you are prompted to set the debug level. You'll learn more about debug logging levels later in the video. After enabling debug logs, restart the client service. Then reproduce the issue and gather logs. When finished, turn off logging and restart the management client service. Note that you can also collect debug logs using SymDiag. For more information on this topic, see the KB on the screen. Detail levels determine the amount of information recorded in the log file. To set the debug level in the registry, create the following dword value. Then set the level to 1. Create a debug log file size dword value to specify the maximum log size before rolling over to the new log. For example, 50 megabytes. Here's a breakdown of the different logging levels. Always make sure that the debug information is set to level 0. Level 0 profiles everything that is happening behind the scenes and expedites the troubleshooting process. For more information on this topic, see the KB listed on the screen. The client computer uses Sylink to communicate with the management server. Stop the semantic management client service, then enable logging at the following registry location. Create a new string value with a value named dump Sylink. Set the value data for dump Sylink to the location to place the Sylink log in a particular location. For example, c:\\Sylink.log. Make sure to test the semantic management client service for the changes to take effect. For more information, see the KB listed on the screen. Note that Sylink logging requires SMC debug enabled on the system. Let's talk a bit about how to enable debug logging for Mac and Linux clients. To enable debug logging on the Mac, you can run the lengineer command from terminal and restart the SYMC daemon for the changes to take effect. While logging runs, reproduce the issue and then turn off logging. Run the gather semantic info tool to collect debug logs and other useful information. For more information on this topic and more, see the KB listed on the screen. SMC logs are located in the Application Support directory on the Mac. You can also review the log history within the Semantic Endpoint Protection UI. Enabling client debugging on Linux requires the file to be created underneath the etc Symantec sep directory. After creating the file, restart the SMC daemon from terminal. At that point, silent communication is logged to the file path specified in the log4j.properties file. For more information, see the article on the screen. Sep for Linux logs are available in the var Symantec logs directory. Let's take a look at how to research a client communication issue. During the research phase, you may be enabling debug or reviewing articles in the Semantic knowledge base. You could also be engaging semantic support. When researching an issue where the client is not communicating, search for keywords such as error or failed in the debug.log. In this example, the client failed to download one or more commands from the SEPM. You can learn more about the commands that it was trying to download in the command status view under Monitors. For network threat protection issues, search for the IP address or process name that you suspect SEP to be blocking. Here are some of the type of entries that you'll see in the debug logs when debugging is enabled. Here's a silent.log example. You can use the silent.log to monitor a heartbeat session. Let's take a look at some repair and validate scenarios. If you need to restore communications on a client computer, there are several different methods that you can use. In the SEPM, launch the Client Deployment Wizard and deploy an updated communication package for Windows or Mac clients. If you have direct access to a Windows computer, you can also use the Silent Drop tool. If it's a large group of computers, you can write a script that runs it automatically. Another approach is to export the silent.xml file and import it directly on the computer. For more information on this topic, see the KBs listed on the screen. In this final topic, we'll cover how to identify communication issues for Mac and Linux clients. If you need to check the client status, you can open the Sep for Linux interface. Depending on whether you're using GNOME, KDE, or Unity, you may have a shield with a green dot. Otherwise, you can check the last connected status. You'll notice that the icons are very similar to Windows client icons. On the Mac, you can force a policy update and check the connection status by clicking on the shield and selecting Management. Sep for Mac client information is available within the SEPM and SEP client interface. The client interface shows the policy serial number, SEPM server, and current location. If there are communication problems between the SEPM and client, replace the existing silent.xml with a new one from the SEPM. You can also restore client-server communication on a Mac by creating a package using the Client Deployment Wizard. In this example, I'm copying the silent file to the SMC directory. For the changes to take effect, I'm restarting the SMC daemon. Now I can see that the client is communicating. In this lesson, you learned how clients communicate with the SEPM and the differences between push and pull mode. You also learned which files the client uses to communicate with the SEPM and restore communication when necessary. Finally, you learned how to monitor the client status using SEPM reports in the client view. For more information about the topics discussed in this lesson, refer to the resources listed on the slide, and remember to frequently check the Semantic Support website. Thank you for watching this lesson video.